I'm Kassandra.eth, KZG.eth, anything with a K, you can call me Cass. I work on this Kohaku initiative inside the EF. This is something, a group inside the EF, as well as a bunch of grantees all working together on improving R&D around the access layer to make sure that privacy is a first-class citizen for users in current Ethereum and, of course, in the future Ethereum. So making sure that it's possible to have a private user experience on Ethereum. So we want privacy by default on Ethereum, and that's what this talk is about. I'm going to try to move through my slides. In the age of AI, I decided to have the most ugly possible slides and most boring slides ever instead of making them pretty for you. And I'm hoping to move through this pretty fast so I can do some live demo here, because the real goal is to show you guys how you can actually get privacy on ETH L1 as soon as possible. We'll see if that works. Okay. So Kohaku wants to bring privacy by default for Ethereum users, specifically at the wallet layer, right? Users using their wallet just naturally get transaction privacy. This is what we want, but how can we do it? And of course, it's really important to remember, most of you here already know, I imagine you have context, you've used Ethereum wallets, most people. There's almost no transaction privacy on Ethereum today. Certainly none of it is embedded by default in any of the classical wallets you might use. The users who do go above and beyond to use the tools that the infrastructure we have deployed for privacy to actually achieve some transaction privacy themselves is an extremely small group. Something less than 1% of all transactions are actually private on Ethereum today. So how can we improve this? What we need to do is we need to innovate on the Ethereum wallet and its de facto standards. So we have some enshrined standards and some that are more kind of implied by the user experience of current wallets. And some of these really need a shake-up and we need to change them. For instance, most wallets today, we actually think of a wallet almost as an address, or a wallet is maybe like a bag of addresses. But when you interact with Ethereum, you usually have some sort of toggle where you toggle between addresses, and then at each address you see balances and you take actions, and you think of this address as something like a namespace for you as a user. And to me, this is one of the biggest things that we need to disrupt, because address space can be thought of actually as something very low level in Ethereum now. And even on Bitcoin, you have the idea of a wallet is some aggregation over address space. You have UTXOs in many different addresses, but you see the aggregate balance and you just operate on your wallet. We need something similar like that in Ethereum today, and we can have it. So yeah, we need to shake up the Ethereum wallet de facto standards, and we need to enshrine some new standards that make privacy something more general, something more standard, something that all the wallets are implementing. So it's a big job. We're working on it. I want to talk about three things today, quickly, that we're working on. And I want to mention privacy on Ethereum. We recently have decided to think about it in three core pieces, and we're going to focus on one piece today. But just to name them, there is privacy of rights. So the actual data that gets written on the Ethereum blockchain, we want to make sure that that has some obfuscation, doesn't necessarily link certain users to their activity and link their activity across different transactions and so forth. So this is the privacy of the stuff that's actually written on the chain. This is what we're going to focus on mostly today. But there are two other categories that are very important for the Kohaku initiative as well. This is privacy of reads. So this is the idea that when you ask for data from the blockchain, just not writing, but just reading, seeing different balances of different addresses and so forth, seeing the state of different smart contracts, that this can be done privately. So that when you ask an RPC, is there a way that the RPC can serve you that data without knowing what they've served you, or things of this nature. So privacy of reads is also equally as important as privacy of writes. And then finally, something similar to rights, but not exactly the same. It's a third, let's say, a third branch of privacy on Ethereum would be privacy of, let's say, network level privacy, or private propagation. So this is about when you actually try to communicate, when you send the transaction you want to write, or when you send the data that your request to read some data from Ethereum, can you stay private? Are you leaking your IP? Are you de-anonymizing yourself in this process? So all three of these layers are really important for privacy. But today we're going to focus mostly on privacy of rights. And in my view, this is like a solved problem from a technical level. We just need to patch together the UX to make it legible for users. So I want to show you how we can, the little bits of standards we can organize around so that we can have this, and then talk a little bit about how we make it legible. Okay, so 3 things I'm going to focus on: key derivation, transactions themselves, and then this question of legibility. So, key derivation. The one very simple thing, one piece of infrastructure we have on Ethereum that we want to leverage as much as possible are these quote-unquote shielded pools, or mixing protocols. So these are protocols like Tornado Cash, Railgun, privacy pools, and they allow you to anonymize your funds, any tokens you might be holding, by placing them into a shared pool. Lots of people make deposits into them, and then you break the link between the deposits and the withdrawals with zero-knowledge cryptography. So you can withdraw from this pool in such a way that nobody knows which of the deposits this withdrawal is linked to. So these protocols are awesome, and you can already use them on Ethereum today, but very few users are using them because you have to stitch this together yourself. This is not baked into your wallet. So the main work we're doing at Kohaku, we're building the Kohaku SDK, and this tries to make it really easy for wallets to integrate these protocols. And alongside this, we want it to be a standard to be able to find the assets that you have inside of these privacy protocols. So one piece of friction today is if you want to use something like Tornado Cash, you need to actually hold on to these secret nodes yourself, and you have to deal with manage these secrets on your own, separate to any other wallet infrastructure you might be using. You also have to make sure when you withdraw to a fresh unlinked account, and that you never, de-anonymize this account by linking it back to your other more public accounts. All of this is something you as a user have to do by yourself. So one key simple thing we can do is when you have a wallet seed phrase, already a standard on Ethereum, we just need a standard path on the derivation path to find the secret material for the different privacy protocols. So that if the main goal of standardizing something around key derivation for privacy protocols is the idea that, let's say you are using this wallet, it integrates Railgun and Tornado Cash, you anonymize some funds, you have some funds in there, you have some ETH and other tokens inside of these protocols. Well, then you, lose access to your wallet, you start up on a new machine, you take your seed phrase for your wallet, and you plug it into a completely different, let's say, wallet client, and still that wallet can open, take the seed randomness, derive the secret information from there, and voila, find all your privatized funds in Tornado and Railgun right when you sync up your wallet on a new piece of software. So we want the secret data for these different privacy protocols to be enshrined in such a way that every wallet, when they take a seed phrase and they know where to look to find your public funds, to find the different addresses you might use as just like public addresses, it'll also find all your private funds, all your notes and UTXOs inside these protocols. Okay, I'm going way too slow, so the demo's probably gonna be off. Let's see. Key derivation, that was the first piece. Next piece, and this is what I think what got me involved in this Kohaku project was I got really excited after the release of 7702. This is an upgrade that allows you to make EOAs act like smart accounts on the fly. And this is what made it possible for us to dream of an Ethereum UX similar in simplicity to the one you have today, and just as general. When you use some browser wallet, you go to a front end, you decide you want to interact with some protocol, and then your wallet simply, figures out the payload and the signing and the gas for you, and you just do the interactions you want to do. That you can have this exact same feeling on Ethereum, but actually you can do it in a way more private way. And this is now possible with the types of tools we have available. So I want to talk about how you can have like fully private transactions, but still do generalistic things like swap and mint NFTs and stake your tokens and, bridge to another network, but do this in a much more privatized way. So the main idea is to use the 4337 standard. So to use the, we don't have fully enshrined account abstraction on Ethereum, but we have 4337, which is basically something close, let's say. And we want to build user operations so that you as a user, you just want to swap some tokens on Uniswap. You want to take some ETH and you want to swap it to buy some, get some DAI. I don't know. When you do this, if you already have some funds, let's say you have some ETH shielded in one of these shielded pools like Railgun or Privacy Pools or Tornado Cash, you can instead construct a user operation where you will remove the funds from the privacy protocol into a fresh address, also where the secret to unlock that address is also derived from your basic seed phrase. You will then synchronously after that be able to append arbitrary calls like the swap you want to do on Uniswap. So the funds will flow from the privacy protocol into the fresh address, and then you'll do this swap on Uniswap, swap the ETH that falls in there for DAI, and then finally, you'll pay the gas, you'll pay the fees for gas back to the relayer with some privatized funds inside of Tornado Cash, let's say. And so all of this can happen synchronously under the hood, so you just feel like you're swapping on Uniswap. You could now dream of a UX where you're using a browser extension wallet, you say swap on Uniswap, it says, do you want to use private tokens for this? You click yes, you click swap, the thing happens, and then when you look at your balances for your wallet, you see that you have some DAI and a little less ETH. But under the hood, you have like fully anonymized what you've done, and the only thing that happens is there's this new account that the only public link is that some account received some ETH and swapped it for DAI and paid for that with Tornado Cash. So this is all completely possible now. So exciting. Nothing stops us from doing this today on Ethereum, but we don't have it. And the reason is because we need to shake up a little bit this user experience. You have to now imagine, right, if you want to truly be private, now every interaction you're going to do with one of these dApps is going to come through a fresh account. Or maybe a few times if you're doing something long-lived, you might have to reuse an account to, let's say, keep topping up a certain position if you have a collateralized debt position on MakerDAO. But you're going to have funds scattered across many, many different accounts. And so we no longer are going to be having this model where you're going to have a drop-down and think about each address as an account that you operate from specifically. Instead, we're going to have to think about a more robust, a wider wallet abstraction, right? Where you just see the funds in your wallet, and if you want to know about this low-level address details, you can, but this is now considered very technical detail. But of course, if you were to take your seed phrase and go to a different wallet, you'll still find all your funds, right? This is the idea. This is possible. Nothing stops us from doing it, but we need to make it legible for users, right? There's a lot of technical detail here, so we need to wrap it up in a way that makes it simple and achievable for users, but we also need to expose enough data for users that they understand what they're doing, they know about the different trade-offs that are being made. For instance, how private are the funds that you're about to use when you do this swap? For the longer you sit inside of these shielded pools, the more anonymized your funds are. They're almost trivially de-anonymized if you were to simply put them in the privacy protocol and then 1 minute later pull them out, right? So things like this are going to be really difficult user experience challenges to figure out. So yeah, how long? Anyone tell me how long have I been so far? Okay, yeah, okay. So now I want to show you how we need to do this today, right? So let's just start doing it right now. So I'm building a CLI tool. It's just a personal project that consumes the Kohaku SDK to show you that it's real, that you can use it to build these user experiences with these privacy protocols and make it simple and possible. So here we go. I'm going to use my CLI a little bit and show you what's up. So I was going to show you first that you can just create a new wallet. So let's create. Okay, we're just creating this wallet, new wallet. I'll make a password. I would save this seed phrase. And there you go. You've got your wallet, new wallet. It's created. We are not going to sync this wallet right now because it would take a few minutes. The first time you sync with privacy protocols, it takes a few minutes. So instead, we are going to use another wallet that I just created a few minutes ago. So let's check out the balances of this wallet first. Okay, cool. So I can see my different wallets. I'm going to select ETH Demo Day wallet, put in my password. Okay, cool. So we've got this CLI-based wallet. It's based on just a single seed phrase that you need to back up. We've got some errors in here. This is a fresh demo, by the way, right? I'm working on this as we speak. So here we go. We're looking at our balances. So we can see just like the total aggregate in our wallet, in our public funds. And we have 4.2 ETH. We've got 125 USDC. We don't have any money in Railgun. We don't have any money in Tornado Cash. And then if we want to see a breakdown address by address, we can see that if you put the verbose flag. Okay, let's deposit some funds into, let's shield some funds. Let's put some funds in a privacy protocol. What are we going to use first? Someone call it out. What do you want? Okay, so we just say shield. Okay, great. So now we are shielding some funds. We're shielding some ETH, but if you wanted to shield a different token, you just pass like a token argument. Opening up the wallet. It's going to ask me, how much do I want to shield? Let's shield 0.2 ETH, just to show you how this works. And I need to pick like the source account to do this from. I only have one. So I'll do it from there. Okay, now I'm going to have to do this in two parts. The log is actually a little bit wrong, a little bad, because we're going to do two deposits into Tornado, into the 0.1 Tornado pool. So we'll do the first one. Okay. It's going to take a second with the chain. So yes, the goal here is to, as quickly as possible, show people that you can actually interoperate with these privacy protocols. You don't have to be a cryptographer yourself. You don't need to stitch too many front ends and different things on onus on the user themselves to figure out how to use these privacy protocols correctly. Okay, we want to do the second one. And just trying to make it a little simpler to see how you'd really use Ethereum in a private way. Because everyone knows about how you could do this, right? But how many people actually are doing this? Or raise your hand, how many of you are interacting with Tornado or Railgun for your... Okay, pretty cool. Nice, you guys are cool. All right, so we shielded some funds. Let's just check out our balances again. This. You can kick me off the stage whenever, because I could go forever too, but yeah, you gotta be done almost. Okay. Cool. This is gonna take a second again. We're gonna see the error again. Yeah, I gotta fix that. Okay, great. And we can see, oh, nice. Now I have a little bit less ETH. I got some money in Tornado. Guys, come on, it's not too important. We're not done. We're not done. We got to at least do a round trip, right? Also note that up here we could have checked out the transactions. You can see, this is actually happening on Spolia right now. But let's just move on. We're almost done. So, unshield, right? Now, we want to take some funds. Okay. All right. I spelled broadcast wrong. That's cool. So this is the part I'm really proud of. So first of all, it asks, we just want to unseal some funds we have in Tornado, and where are we going to send them? Well, it just right away says, well, do you just want to generate the next public address on your account? Yes, I do. So let's unshield there. Okay, we have to sync a little bit with Tornado Cash to make sure we can make the zero knowledge proofs. We got let's unshield 0.1 ETH. All right. So we've done a lot of work at Kohaku to make sure that you can utilize all these privacy protocols without relying on their relaying infrastructure. So most people use privacy protocols, but in order to relay withdrawals, you use some relayers that are run actually by people specific to that protocol. And if that infrastructure goes away, then so does your ability to transact privately. So we're making sure that you can use all of these protocols with the classical 4337 mempool instead. So as far as I know, this is like first of its kind. We're the only ones relaying Tornado Cash transactions in this way. And the other thing that's awesome about this is that then you can append arbitrary calls after you're unshielded and do things like I was saying, swap, bridge atomically after unshielding. And we pay gas to the relayer directly with privatized funds as well. So this is all really cool. All right, we're building the proof. Taking long. What's going on, bro? So as I was saying, we are making that possible on all three protocols. So this is like the dream is to eliminate one of these potential choke points or points of failure or censorship, which are like the proprietary relayers. Okay. There we go. Yes, I would like to broadcast this. So now I am sending a 4337 user op bundle to Pimlico, who is then going to bundle my transaction and do the withdrawal on my behalf. And we should end up with not exactly 0.1 ETH in the fresh account, maybe just slightly less. We'll see when we check out our balances, because we have to also pay for the gas. So, okay, cool. So I want to show you that it worked. So first thing, let's open up this transaction link. You can see that it's a account abstracted transaction. There we go. I know I gotta go. All right. Okay, here we go. You can see we've done this AA transaction, right? So we've done something through the 4337 mempool, and we have, let's see if we can find and we have 0.097 in this new fresh address. So as we can see, now we can see the totals, public totals. We have some USDC, we have some ETH. We have a little more public ETH now, because in this fresh address, in the index 1 on my wallet, I now have received a little bit of ETH. And we can check out that address here and see that it has no transactions it's ever done. The only interaction it has is this interaction with this 4337 bundle, and now it's holding ETH and could do some transactions privately. So this is where I'm at. I'm working hard to make this more private. Private Ethereum transactions is possible. You should all be experimenting with it. We all will be soon. Thank you for your time. Goodbye.